hope everyone is doing well. So welcome to the channel. I'm 3 Crunch. So here we are going to learn different languages, just like C, Python, C++, Java, and all. So here we'll start with the basic things. The languages that are the programming languages are divided into two categories, just like object-oriented program as well as procedure-oriented program. So here to learn them clearly and betterly, we can make differences between them, and we can see here as the first point is what programs divide into objects and classes. In the object oriented and in the procedure oriented, it is program divided into functions. So whatever the program that we write, that are divided into objects and classes. What is objects and classes? We'll learn it in later classes, but for now, for example, if a fruit is a class name, for example, it's a fruit is a class name, and inside that apple, orange, chicken, and all are objects. Same like that here, programs divided into functions, there are many functions. We'll know what is function in detail later on classes. Okay, so second point is what it emphasizes on data. So the object oriented programs, they more stress on the data, whatever we write, whatever is going to happen. But in the procedural oriented program, the emphasizes on doing things, means what is going to happen. It more emphasizes on the stress on that. What is the third point? Third point is it is easy to maintain product if it is too complex. If the programs are too lengthy, we can divide it into parts and we can solve them. But here we can't do like that. It is not really easy to maintain project if it is too complex. Now next point is what the provides strong data security. Okay, we have data security here, and for the procedure oriented we don't have much high data security. Fifth point is it is highly extensible programming language. Means it means that the programs is very extensive. For example, we take Python. Python is an object oriented program. So here it has vast applications such as making websites or apps, gaming apps, something like that. And for object or procedural oriented programs, it is not highly extensive. It is just limited one. It doesn't have vast applications, but still it is the basic or the strongest part, we can say, of the programming language. So next first we come across is design and implementation of efficient program. So it is nothing but what are the steps we follow for writing a program. Okay, so what is the first step? First step is requirement analysis. Second is design, which includes algorithm, flowchart, or pseudocode. Third step is implementation. Fourth is testing. Fifth is software development, deployment, training and report. And sixth one is maintenance. So first step is what? Requirement analysis. In which step what we do is we analyze what are the requirements that we need, what are the things that we need. For example, sum of two numbers. In sum of two numbers, we need at least two numbers to add. Okay, so that is what requirement analysis is. Second step, design in a sense, like algorithm, flowchart, or pseudocode. We'll learn later what is algorithm, flowchart, and pseudocode, but for now algorithm is just English writing step by step. But what we have to do, for example, for cooking something, we follow some step. We have recipe, we have certain steps to follow one by one. Same as it is, algorithm works the same way. What is the flowchart? Flowchart is nothing but the symbolic representations. For example, for in algorithm we write step by step. So there is first step, second step. What is the first step? First step is starting. So in flowchart, starting is represented symbolically. In a sense, there are different shapes, different kind of shapes, whatever we do. So here that's the thing we follow. What is Sudoku? Sudoku is nothing but we write code, but it is not exactly the executable code. It is the false code. Okay, so design is nothing but we write step by step what is going to happen or what is going we are going to do. Third step is implementation. What is implementation? We write the code, we combine all the codes, we like we write different parts of the code, then we combine it, and then we just write it together. In the fourth step is testing. Testing was what we do in the third step is we write all the codes. In the fourth step we combine all the codes and we execute it. We find some other if there are any errors are present or anything else, or something like that. What is the fifth step? Fifth step is software deployment. After testing means when we are successful, or like when the code is running correctly or whatever we have created is good, then we go for software deployment. Software deployment is nothing but giving our whatever we have created, just like code or app, we give to someone or sell to someone who is well experienced in that, who can give us feedback, and if there are any changes required or any errors are there, so that they can, or we can train others like using the things. Just like an example, that is WhatsApp. How was it before WhatsApp? Okay, no one was knowing what is WhatsApp, but nowadays everyone knows, even a kid knows how to use WhatsApp. So this is what training and report is. Sixth is maintenance. Maintenance is like updating or adding features to the app. For example, WhatsApp, same example. So what was before this WhatsApp was, we don't have Meta, we didn't have any channels in the WhatsApp, something. Now we can see is all are present. Meta AI is there, features are there, we can create our channels, something like that. And the maintenance cost, it should not increase by 25%. If it increases 25%, more than 25%, then the application or the code whatever we have created must be destroyed or must be discarded. So these are the different steps that we have to follow. Here we go in the detailed about the step that we studied. So in this phase, users' expectations are gathered to know why the program or software has to be. For example, I gave an example of a sum of two numbers, where we are adding two numbers and getting the output, whatever the desired output we need, or whatever the numbers we get. Okay, so here we are gathering what is actually to be done. Next is what are the requirements, like what we need actually to adding of two numbers. We need two numbers first, then we have to follow the next step. So this is what says. Basically it is in a simple word. The functionality, capability, performance, availability to hardware and software components are analyzed in phase. In case we are doing some other projects where we need hardware as well, instead of including software, we need hardware as well to work. For example, we see hackathon. Okay, in hackathon what happens is, we write code, we implement to a chip, we what to say burn to a chip, and then when we press it, it shows number one, or whatever the code we have written, it shows the output. This is how it happens. We come to the second step, design requirement. So as I said, what is design requirement? We follow algorithm, flowchart, or pseudocode. So here the requirements documented in the previous phase act as input to the design phase. So for the design phase, the whatever we have gathered before in the requirement analysis, that act as input to the design phase. So it is the plan of the action is made before the actual. So for going somewhere, first we plan. For example, we go for a trip, then before going there we make plan, the what are we have to do, what are first day, second day, third day, like that. So this is the plan, where it is just nothing but the process, and the plan that we make, we follow throughout. Okay, so for example, the trip, we think like we are going for certain place, then we have to, for example, Delhi, we go for what first we do is, first we go to Taj Mahal, then we go for some other places. Okay, something like that. Then we plan it, what is first day where we have to go, second day where, same as it is here as well. In the code, in the design phase, whatever the inputs we have taken in the requirement analysis, here it is just the act as input, as well as we plan what we have to do in our code. Okay, moreover, the design phase are the structure of the software or program broken down into the modules. Okay, what if the course or the program is very lengthy, we divide it into different parts, so that it is easy for us as well to create it and to understand it. The solution of the program is then specified for each module in the form of algorithm, flowcharts, or Sudoku. As I said before, that each program, each small course, what we write, we divide it into small modules. Small module in a sense, small parts. Okay, algorithms. As I said, we just write in normal English, step by step. Like after one step, what is the next step? Same as the flowchart is the symbolic representation, and pseudocode is nothing but it's a code, but it is not exactly executable code. Where we write just logics, we understand it. So this is our design phase. Third step is implementation. In this phase, the design algorithms are covered into program code using any of the high level languages. High level languages is nothing but the language that we are going to learn in the upcoming classes. Okay, so implementation, the whatever we have planned in the design step, that we are going to implement it here. We bring them together. Okay, so that we can do whatever the changes we have to do. We check it line by line. So it is something like that. The particular choice of the language will depend on the type of program, like whether it is a system or an application program. For example, Python code. In Python, we go to Python, we open the Python, then we write their code. That is the system code. Application program is like we are going to create apps, something like that. It is equal to something like that. The third point is the phase is also called construction or code generation. Software is the generator in this phase. Okay, it is nothing but the where we generate the code, like we bring all the codes as we have designed before, according to the design, according to the algorithms, according to the flowchart, or the pseudocode. We write codes, we bring them together here. We are just generating the code. Okay, here we come with the first step, that is testing. The whatever the code we have created or developed are going to be tested. In this phase, all the modules are tested together to ensure that the overall system works well as whole product. So all the modules, all the test means whatever the code we have created or in different paths or we have made together, we are going to get the output, our desire. If we don't get it may have some error, so we can change the errors, we can fix the errors whatever we just generated. So all the individual piece of code are already tested by programmers in the implementation phase. So some of the codes, like we create the code separately, then we join them. So there uh, some of the codes are already tested by whoever is creating, or the programmer is the creating the code is checking before the testing, and there is always a chance for bug to chip in the program when the individual models are integrated to form the overall program structure. So here first what we do is we create the uh, codes separately in a group wise or in a path in the modules. Then when we combine it, there are chances that error may occur, bugs may creep. Bugs may creep in a sense, like errors may happen, so that we can, so in the testing process we can find it and they fix it. So this is our first step, that is software deployment, training and support. As I said before, that we give our code or the application whatever we have created to some of the experienced person who can give us, who can use our application and the code as a user, and can give us the feedback, so that if any changes is required we can change that. Okay, so here what is the point is given that after the code is tested and the software or the program has been approved by the users, it is then installed or deployed in the production environment. That means once it is approved by the some of the experienced person or who are work at the higher level, so they, we what we do is we just give access to everyone, we launch it This is what it is saying, that it is then installed or deployed in the production environment so that everyone can use it here. This is what it's saying. And many of the developers, they ignore this step because they feel that my code is good, my application whatever I have done is good. So this should not be done, as this is an essential step. Because if in testing we get, we execute our code, we apply our whatever the code we are programs and all we do, but we get the output as well. But there are something might, something might be bug, or what we can say, something might be not good or may need by the user end, but it's not that. And by going through this fifth step we can get to know that, and we can correct it. That so that's what it's given here, that software training and support is a crucial phase which is often ignored by most of the developers. As I said, it is given here. Okay, we'll go for the next step. This is our maintenance sixth step. As I said before, maintenance is nothing but upgrading or adding features to our whatever the application or the program that we are doing. So this is what maintenance and enhancement means nothing but the same thing, upgrading. So maintenance and enhancement are ongoing activities which are done to cope with newly discovered problems or new requirements. What we do is, for example, take WhatsApp as the example, or you can take Instagram, or you can take any social media or whatever the apps or whatever the games. All kinds of apps or all kinds of applications, programs are featured, they are upgraded year by year, or in a regular particular period of time. So this is what the maintenance means. So maintenance and enhancements ongoing activities which are done to cope with newly discovered problems or new requirements. Okay, what are the new requirements we according to the user, and we upgrade. This is called as maintenance. Such activities may take long time to complete, as the requirement may call for addition or new code that does not fit original design, or extra piece of code extra piece of code required to fix an unforeseen problems. So what is it saying? That it is saying that we have created an application. Okay, for example, any game, we have written codes, back end, front end, everything, it is completed, we have launched it, we are upgrading it now. So while upgrading, we have just, like, the codes are limited in a sense that whatever the code we have written, that is fixed to that particular app, game, or whatever it may be. When we try to add extra thing, it may take long time to fix. We have to create more space to that, so that we can add our codes. Okay, this is what it's here. It is saying that a new code that does not fit the original design, or an extra piece of code required to fix to unforeseen the problem. This is what it's saying. Second point, as a general rule, if the cost of the maintenance phase exceeds 25% of the prior phase cost, then it clearly indicates that the overall quality of at least one prior phase is poor. As I said in the starting, that if our code upgradations, maintenance, or features exceeds 25% of the prior phase cost, then it is clearly indicates that the overall quality of at least one prior phase is poor. That means is, if our maintenance cost, like last time we have spent 100 or 200 rupees, next time when we feature we spend 1000, that is more than 25%. So if that is more than 25% means there is some or the other mistake, or something else is, or the quality of the particular that application of the or the program is not good. Okay, so, and if for example, if we spend last time 10 or for example, we have spent 100 rupees, okay, for upgradation of our feature of the application or the code. Then next time when we upgrade it, we what we do, we spend 150, 125 rupees. So this is 25%. We are using this 25%. We are not exceeding 25%. It is less than 100 is 100 is overall 100%. 25%, 25 we are using as the our 25 upcoming or the next cost. Now the next one, in such cases it is better to rebuild the software before maintenance costs out of control. So as I said before, that if the maintenance cost exceeds 25%, we need to destroy our program or the software. We have to rebuild it again, because it may go out of our control as well. So this is what the things that I would like to say right now, that the basics of the thing that we have covered, that is what are the steps required to write a code, and we have known in detail. And we also know the difference between what kinds of program we have, that is two types of programs, that is object oriented program and procedural oriented program. So this is our first thing. Thank you for watching, and I hope if you like it, please like, comment and subscribe. Thank you.